Now we're going to be talking about relations and functions. You've had this in Algebra 1. So this is kind of a review over what you had. So a relation, it's a set of ordered pairs. So it can be shown in a table, a relation mapping, a graph, or it can be expressed as an equation. Remember, ordered pair is something like x, y. So the set of x values is called the domain, and the set of y values is called the range. A relation with distinct points is called discrete. And a relation with connected lines or curves is continuous. There's not a break in it. Now, functions are a specific type of relation in which each element of the domain is paired with exactly one element of the range. So a function, for example, would be the set that includes 0, 1. This is just an example. -5, 2, 6, -2, and 5, 7. That would all be a function because there aren't additional zeros in there. 0 is just paired with 1. -5 is only paired with 2. So if we look at the ones that are not a function over here, this is the set that includes here I've got 6, -1, and 6, 2. So the reason it is not a function is because 6 appears twice. So the x value 6 was paired with -1, and it was also paired with 2, which means it is not a function. And that doesn't happen over on the left when they are. So the vertical line test, in order to be a function, a vertical line cannot pass through more than one point in this relation. So here we have an example. So there's a function. This one's not a function. And let's look at y. If we put a vertical line through here, that's 1 point, and it does not cross any other. But if we put a vertical line here, it crosses here and there, not a function because it has 2 points. So domain, we are going to do this little set that includes again, and we're just going to list off all of the x values. And then the range is going to be all of the y values. Domain down before, we're going to put them in order. Down below, I don't know why I said before. Put them in order from the lowest to the biggest, just like it would be on a number line. So I skipped the part about the function. Remember that each member of the domain, or the x values, has to have only one y value. So yes, this one is a function. And up above, also a function, because none of those x values repeat. None of the y values repeat. All right, so over here, this is just a mapping to show that you've got x values, -4, -2, and 5. But the y values, the range, we have 0, 3, 7, and 9. So this is not a function because of this, that 5 has 2 different values that are there. Not cool. So here we would start over on the left with the lowest of our x values. I've got x equals, there's -1, 2, 3. So x is -3 here. And y is 1. This one's also -3, but y is -2. Then, of course, up to this one, x is 0, y is 4. Then we've got x is 2, y is -1. And down below, I have 1, 2, 3, 4 for x. And y, 1, 2, 3, 4, 5. So you would just put these in order for the domain, starting with the lowest, -3, 0, 2, and 4. We don't actually repeat the -3 in there. Then the range, -5, -2, -1, 1, and 4. So is it a function? No, because -3 has 2 different y values. Okay. Let's look down here at number 9. So on this, we're going to say the domain is, here we've got x, 1, 2, 3, 4. So this is -4. And then the y value is -1. But -4 is the farthest left that it goes. So the domain is -4 and anything bigger. So I'm going to say x is greater than or equal to -4. Now for the range, you'll see it goes forever and ever and ever up there, forever and ever down there. So it can actually be all real numbers because it's going up high for y and down low for the other part. Because it's going forever and ever in this direction and forever and ever in the negative direction. So that's going to be all real numbers. And is it a function? If we do our vertical line test here, it goes through 2 spots. So no, it is not. Going to skip number 11. Then if we look over here to y equals mx plus b, do you recognize that as the slope intercept form of an equation? So this is our slope, the m part, And this is our y-intercept. So on this, when you graph something like this, your slope is negative, so it's going to look something like this in your graph. We don't actually have to graph the whole thing to see what it is, if it's a function or not. It's just going to be a negative thing whenever you have the y equals mx plus b. You do your vertical line test. This is linear, by the way. So it always just makes a one line that looks like this. Negative slope goes that direction. And so you do your vertical test and it only is right here. So yes, this is a function, and any of these linear equations, you're going to have all real numbers because it goes forever in both directions, y and x. Then if we were to graph y equals -7, thinking about what that looks like, you'd have y value, no x's, so the x is 0. Your y is 1, 2, 3, 4, 5, 6, 7. So there's -7. And when you graph that, it is just simply the line that goes through this way. So your domain is all real numbers because it goes forever and ever. It doesn't stop anywhere. Your range is specifically y equals -7. Is this a function? Yes. If you did your vertical line test, it would go at one spot right here. Then go ahead and do this one. X -1 would be the line that looks like this. So the domain is specifically x equals -1 for the x values. The range, being the y values, is all real numbers. Now, is it a function? Can you put all of your vertical line there, and does it stop at just one place? It does not. So this is not a function.